Okay, so this is an introduction to GeoGebra. The symbol is shown on the left-hand side here, and GeoGebra is an online software that will allow you to do interactive geometry. In fact, this is the definition from Wikipedia. GeoGebra is an interactive geometry, algebra, and calculus application intended for teachers and you as students. Most parts of GeoGebra are free. In fact, the way that we're going to access this, the free way we're going to access this, is as a Chrome add-on. So you have Chrome on your computers, and if you don't, you should. And we're going to go to the website that I'm going to show you in a second and add in the Chrome extension so that we can go play with this software. So let's go do that. So the first place that I want you to go is web.geogebra.org/Chrome app. And this is what you should see when you go there. It might take a second to load it up. And what should appear after it loads up is this screen. And the first thing that I'd like you to do is turn the axes off. So go into the space where the Cartesian axes are and right click. And what you should see once you right click is the ability to turn the axes on and off. Right now they're turned on, so I'll just turn them off. And that'll just give us a blank area to work in for when we're doing some geometry. Okay, so let's go to the next step.
Okay, the first example that we want to look at is measuring the sum of two angles on a line. Now at the top of the GeoGebra here, you'll see different icons for things that you can do. You want to select line, and if you click on the little red triangle at the bottom, you'll see all the different options that you've got. Click on segment, and then anywhere in the graphics view, draw a line. You need to press both points for it to draw the entire line. Now we go to that again, and we want to make sure that we're in the line segment, and if you haven't clicked on anything else, you should still be there. And simply draw another line, do a point somewhere in the graphics, and then come down and meet that line. It should become bold if you're going to actually draw a line segment to that line, AB. Now what we want to do is measure the angles between each of these different lines. If we go again to the top and you see that there's the one that's angle, you can see it's going to measure the angle there. Again, we'll go to the top one to measure the angle. Now click on 3 points, and if you need to find out what it is exactly that you need to do, again, if you look at the top there, you'll see that it says angle, select 3 points or 2 lines. So we can either select C, D, A, and it will measure that angle. Okay, let's find the other angle here between angle CDB. So again, we'll choose points C, D, and B, which is not giving us the angle that we want, so we can delete that line or that angle and go and choose B, D, C. The order is important when we're choosing which those angles will be. Now, our example was to try and find the measure of the sum of two angles on a line. GeoGebra will actually do the math for us, so let's look at what the sum is of angle alpha and angle beta. If you go down to the input bar at the bottom, okay, and yours should be blank, and you'll see when you're in the input bar that there's a little symbol at the bottom right-hand corner here. On that, you can click and actually choose the symbol alpha. So we'll choose that, and then we want to find the sum, which we remember is to add beta. And again, click on the symbol and then choose beta. And then just hit enter, and it will do the math for you. You'll see under the angle in the algebra window that it says that the angle is equal to 180 degrees, which is what we should remember from last unit. Now if we want to check and see that that's always the case, go up to the top and click on the move icon, and that allows us to adjust where we've actually got our point. So we can go over to point C and we can drag and move it, and what you'll see is the angles change as we move it along, but what are you seeing happen to the angle, which is a sum of alpha and beta? Now at the end of each of the challenges that you're going to have as you're working through GeoGebra, we're going to be asking you what conclusion can you make. You can see that I've typed that in the input at the bottom. So take a moment and think about what conclusion we can make about the sum of angles on a line. Our conclusion for this example is that the sum of two angles on a line is 180 degrees. Now we could of course go in and add other line segments on AB, measure those angles, and we should be able to conclude that the sum of any angles on a line is 180 degrees. Now let's take a look at the next example. For the next example, let's look at the measure of the sum of angles at a point. We already have a line with a segment to it, so let's consider point D and what are the angles all around that. Now I have de-highlighted the angles alpha and beta, and I'll show those on yours again. So we have alpha, which at the moment for me is around 27 degrees, and beta is the 152 or 153 if we rounded it up. Now that's 180 as we saw before. Now let's consider all of the angles around point D, so we need to consider at the bottom here. So again, we're going to go to the top and select the angles measurement, and we'll select points A, D, and B, and we'll see that it's coming up with the angle. And as expected, it's 180 degrees for that angle. Now let's see what the sum of our angles around point D are. We can go back to where we calculated the sum of just angles alpha and beta, and if you double click on that, you'll see that we can redefine what we're doing there. So let's add our new angle, and again go into your symbols and select our delta there and apply that to our new definition. Click OK. What conclusion can you make? The sum of angles at a point is 360 degrees.
Okay, in this example we're going to go ahead and measure vertically opposite angles. So first of all, I need to create vertically opposite angles. If you don't know what some of this terminology is, there are resources for you. You can use Google. So for some of the challenges you might need to do that, or you can take a look in the textbook. But vertically opposite angles will require us to first of all create some intersection of lines. So I'll create a line AB, create another line CD, and I actually want to get another point where they meet so that I can start to look at some angles. And so there's a feature that allows you in GeoGebra to find an intersection point. So I'm going to use that feature, and I'm going to select these two lines, and the intersection point will automatically be made. And so now if I use the tool that allows me to move it, that intersection point moves, and I can create all sorts of different angles just by moving these shapes around. So here's some angles that are smaller and some angles that are bigger. And so now I'll use those angle measurement tools, and I will select to create vertically opposite angles. So this is a vertex. The point E is a vertex, and vertically opposite angles are the ones that are across from each other in the vertex. And let's just set that up fairly quickly. Quickly created two angles like I did in the last like we did in the last examples that are opposite to each other, so angle A and angle Y here, and you can see those two angles. And again, on the move tool I can go and move them, and you see that they change on the right. There they go, changing, and I can use these points to make them change as well. And let me create these other two vertically opposite angles across from each other this direction. And so there's a couple more angles. Now, they're kind of hard to read on the graph here, and they're all green, which makes them a little bit hard to see. But I can see this one here, beta, that's an acute angle in here. And if I right-click on beta here and go to Object Properties, there's a few things that you can do here. So I could change the color, maybe make it orange instead. Oh, beta's across on that side, that's fine. Or make it red or pink on this side. And I can also do some things to the style, so I can make it maybe a little bit bigger, which will make it a little easier to see. And I can go and do that to the angle on the opposite side, which is beta here. And I can go ahead and do the same thing to that. And so now you can see a little bit more visually that those two angles across from each other at that vertex have those angles, and same with the ones up and down. And as I move this, this is dynamic geometry, so everything changes. All the angles are changing as I move any of these points around. And there are features actually that I believe allow you to animate points so they move themselves around, or create sliders to move these around for you as you slide something else. But let's go to the last step of this, which is to ask that same question: what conclusion can you make? And in this case, hopefully you can see, no matter what I do to these points, the vertically opposite angles are always equal. So we write that as our conclusion. Okay, let's take a look at one more example. And to clear the page, I just go File, New, and I clear everything out. And let's create our new challenge, which will be to measure corresponding angles formed by two parallel lines and a transversal. So now there's definitely some language that you might not know. Creating parallel lines in here is fairly easy. There's some tools to create lines, but there's also some tools to create parallel lines. And what we do is we set up a line and some points, maybe like this, set up a point off in space, and then to create parallel lines, we just want to select the line that we have and the point that we want the parallel line to be built through, and go and create that parallel line. And it will create a line that's parallel to our line AB through point C. And so if I move point C around, or if I change where this is, you see the other line stays parallel. So you can move these around so that you get something that you want it to look like. And now we create what's called a transversal. And a transversal is a line that goes, I'll make it go this direction, that goes across, trans means across, the two parallel lines. So we've got a parallel line here and here, and again they stay parallel as we move them, and a transversal that I can move as well. And now there are angles that get created between the parallel lines and the transversal, and so I'm going to use that intersection tool and find some points of intersection. So let me do that really quickly. So I've created F, and I use the intersection tool to create G, so I'm selected on that intersection tool to do that. And now I can start to let me actually just throw a point onto this line here, and you see how it went bold when I'm on the line. I can create more points that way. And now I'm going to start to measure some angles. So I've got quite a bit of information out here already, including a bunch of stuff I don't really need. Maybe you can hide that stuff right now. But we need to go create some corresponding angles, and one of these angles will be this angle here. And again, you can right click on it, object properties, maybe change some things about it. Maybe I've actually clicked on the point instead of the angle, so I'll go to this one and make sure that I have angle alpha, and then I can actually even change the symbol that's on the decoration. So you can choose that, okay, this angle is going to have two lines instead of one line. There's lots of options in here, and I definitely encourage you to explore them. I'll leave that as a green one, but I definitely like having a larger size. It's not changing it in this case. That's okay for right now. The corresponding angle is defined to be in the same place. So this was up to the right. This is up to the right on this vertex. So I need to create another angle here and up this way. And you can see those corresponding angles. Now, if I did the same thing here and here, I will create two more angles. So I'm just going to do that really quickly. So there I've created two more angles. You can see those in blue, and it's easier to use the sidebar, so that's why collapsing this area with the line, it's easier to see the sidebar now, and I don't actually even need to see where these points are, because we are eventually going to get a question for you, which is, of course, what conclusion can be made. And if you can't see the conclusion yet, you could continue to build some more angles. So corresponding down and to the left would be these two angles, and corresponding down to the right would be these two angles. I'm actually not going to do that, so it's similar to what I've already done, but you will then hopefully be able to see guarantee that corresponding angles are equal. And you can write that in as a conclusion.